What's new in the world of computer technology and ceramics? Recently, I was at a large academic conference which talked about humans and their use of technology, and there were a few papers on ceramics, including one of my own on Shapecast. Hi, I'm Kent. In this video, I'm going to do something a little bit different and talk about some of those papers. As I've mentioned in passing in a few videos in the past, my background's actually in research. I've been on the industrial side, but have very close ties to academic research, so basically professors, PhD students, and their work. The conference I was at is basically the largest in the field. It's known as CHI, C-H-I. There are over 5,600 attendees spread over 4 main days of the conference, and there were over 5,000 papers presented, so there's quite a lot of work. This conference covers everything between technology and people. Some of it's very technical, focusing on things like sensors or AI. Other work is much more human-centric, trying to understand people either from a psychological perspective or a social perspective. And there's lots of work in the middle. It covers a wide range of different technologies, and there's been a few papers in the community on ceramics over the past handful of years. And this year there was no exception. There were a couple of papers on ceramics and ceramic adjacent things. And I figured it might be fun to kind of give you guys a sense of what's going on in the research world. This isn't directly applicable to today's practice, but might be interesting in some way. First up is my own paper on Shapecast. Here it is. Here's the title, Crafting the Curve, Automating Plaster Mold Design for Ceramic Slip Casting with Shapecast. This is basically the Shapecast system that I've been talking about and you guys can use. It was an early version of it. And for those who have stuck around for a good while, I did a user study very early on where I basically sent out a survey and asked for some feedback. So this paper is about both the system itself, how it works, and about that early feedback that I got. So the paper has a quick overview of what slip casting looks like. Since most people don't understand that within the community, it's relatively rare. It shows the process, so going from sketch to the preview to the 3D models. It talks about kind of under the hood how that works, creating all the different offsets and creating the different models and then revolving those into 3D. And of course I show some examples of what this looks like in the real world. This is for the very first version of Shapecast, the one that still uses gaskets and the threaded inserts and bolts. I submitted this paper last fall and it got accepted basically early this calendar year, so it takes a little while. So while it was actually under review, I was rewriting Shapecast to use the new groove system. In the paper, I showed some of my own work basically as case studies showing the capabilities of Shapecast. If you go back, I have a video, I think, on some of these. One of the first things I tried was basically a family of forms, where I basically changed the point where the bend happened, and I 3D printed these out as design proofs. There's a surprise that I had very early on using Shapecast, and the profiles all looked good to me on the computer, but as soon as I printed out the design proofs and held them, I actually didn't like 2 of them. I didn't like the 2 on the left. So it's actually one of the reasons I have the design proof in the Shapecast flow. I don't think many of you actually print the design proof, but if you do, I think it can give you a very early sense of what a new design is like. And here are some more case studies. Some of these forms are available on the Shapecast website still. And then here's the sphere that I did, basically making some slight modifications to Shapecast to make a 2-part mold. I have been continuing to work on the 2-part mold process. It's not integrated right now, but if you need a mold, definitely reach out. So I did the study in March of 2024, and I wound up with 17 participants in the study. I reported on some of the demographics of who they were. One of the questions I asked was how familiar people are with 3D printing and how they were with SVGs. I think this has changed now that Shapecast has been out in the wild for a while. Asked about ceramics background, things like that. So basically have an idea who the participants were. The primary question I was looking at on the quantitative data side was this idea of threshold and ceiling. The threshold is basically how easy is it for new people to come into it. Designing molds is relatively difficult using CAD, and so the primary purpose of Shapecast was to be able to lower the threshold so it is easier for everyone. And then the ceiling is the opposite end of that. Basically, what is the system capable of? Are we limited in some way, or can we do everything just as well? So there was a survey that asked a bunch of questions, basically on a scale of 1 to 7, how well you agree. And all of the scores basically wound up being towards the top, which is good. It means that Shapecast was doing what I wanted. Probably the lowest score was barrier to using 3D printing in your process. Again, I think this has changed very early on. I think a lot of people that were interested in 3D printing were using it and probably actually had some CAD experience. I think that's shifted over time. They thought it was easy to use. 3D printing the pieces was easy. The level of customization was good. They thought it was more efficient. The quality of the molds produced was good, and they could iterate more. I think one of the key advantages of Shapecast is this notion of iteration. I've done some other research that hasn't been published yet. I keep trying. where I talked to a bunch of slipcasters, and some of them only made molds once a year because it was such a difficult and invasive process. And one of my own motivations for creating Shapecast is that I realized I needed more practice on mold making, and I was reluctant to do that because it was so difficult. So the hope with Shapecast was that I could make that much, much more easy. That would allow me myself to iterate on my molds and make many more molds, and then the hope was by opening it to everyone else, they could do that as well. I'm not too sure this is really easy to grasp when you're first coming into Shapecast. You have all of this history of doing molds the traditional way, or maybe you don't know how to make them at all. And so getting in and being able to rapidly iterate and make design changes on your molds, I think takes some time and practice, and it's one of the things I want to try and support with Shapecast. I also got some qualitative feedback on Shapecast. Basically, this is asking some open-ended questions and getting some responses, and there's some kind of methods behind this. Some of the quotes that came back: it's faster, the shapes are more accurate, the working molds are cleaner and less waste. Another participant commented on this: it's 100% my own design rather than copying something. I don't have to teach myself another new skill. I can focus on the pottery, and it's efficient, less plaster, it's reusable, and it does the whole thing with the outer molds as well. So these were very encouraging, basically pointing to the fact that Shapecast was doing what I wanted. There are also a variety of limitations. Many of them were around 3D printing itself. So someone had an old printer and the printing part was really annoying, or prints were slow. And several people commented on the lack of two-part molds, which I still get comments on, or more fancy molds. I also asked participants if they're willing to share the designs they'd made with Shapecast, and here are a bunch of them. So doing things like exploring the different heights of the walls. So here with P15 doing this traditional way, if you were to actually make all of these different iterations, it would be relatively intensive. Doing it with Shapecast is easy. People are exploring plates, different bowls, different feet, all sorts of things. And again, this was very early on, so there's been a ton more since then. And then the paper ends with future work, where basically I'm thinking about what are some of the future research questions. Obviously, there's more complex molds, which I think is relatively technically straightforward. It's just a lot of work to do, in particular generalizing. Doing it for one mold is relatively straightforward, which is why I'm offering the custom work, because I can go and make sure that it works. But doing it for thousands of different designs is a very different process. There's lots of corner cases where one little thing breaks and then the whole mold system breaks, and that isn't very cool. I also think there's this interesting spectrum between basically pre-made molds and fully custom molds. So you can think of basically just downloading existing molds, and a lot of you have commented that you're using the designs that I had. I really meant to put those up there as examples and as a starting point for people to use, but a lot of people seem to be happy with them. That's one of the reasons I did the handles to start with that way, was that people could just go and download the existing handles. On the other end are basically fully custom CAD models where people go in and model everything up. In that case, Shapecast probably isn't that helpful, or maybe it's just a shortcut to getting there. And then there's a variety of spaces in between where somehow you're controlling the mold but not fully specifying it. Shapecast is an example of this, where you draw the profile. I think there's other interesting things where, for instance, if you want a surface texture, potentially that could be modeled in automatically. The problem is right now, I don't know how to do that in a very easy way. If you don't know CAD to start with, then you don't want to go ahead and model the surface. So I think there's some interesting questions there. If you have ideas around how you would want to specify a surface texture in particular, I think that would be interesting. I commented on using TPU, and I just did a video on that. And there's a lot of other techniques that I've explored, like CNCing, although I think that has some challenges as well. So that was my paper on Shapecast, and I got a couple of interesting questions, so that was great. There was another paper on slipcasting that came out of the National University of Singapore, and it's this paper here, Slipcasting as a Machine for Making Textured Ceramics. The key idea here is applying a stencil to the plaster. Slipcasting, and what happens is the stencil itself prevents the plaster from absorbing all of the water, so you wind up with a textured surface within the slipcast itself. Overall, this seems like a cool idea. The challenge I saw is that basically you wind up with the texture on the wrong side. Usually the plaster side is the outside of the pot, and the texture you would get with this technique winds up being on the inside. So I think this is kind of academically interesting. I'm not too sure how practical it would be because of that, although they do show a couple of designs where it makes sense. Some of the early papers really about characterizing slips. So for instance, they look at different dwell times and how that impacts the thickness of the walls. They explored a bunch of different resists to apply to the plaster molds. Vinyl was what they used, but they also tried paper. And then here's their overall process. So they make the mold, they then make the vinyl mask, pull it off, apply it to the mold, and then slip cast in the normal way. They drain the slip, remove it. They do a little post-processing cleanup, and then they remove the vinyl stencil and then fire it like normal. There's a bunch of challenges around slip casting and kind of different deposition issues. problems with the vinyl stickers sticking both to the clay and the plaster mold, things like that. And then they run into normal ceramic stuff like getting things flat and keeping them flat is hard. They do some characterization around how the slip is deposited. So for instance, here is a square hole and here is a circle hole. And because of the way slip works and the way it's deposited, the water will actually transmit through the clay as it's being absorbed. So you don't wind up with a shape exactly like the one that you cut out, which can lead to some cool effects. It also happens, for instance, like in the corner of a pot where you have two walls that come together when you're slip casting. The slip there winds up being thicker than it would be on the wall of the pot. So they did some characterizations here and talk about how they can get different effects that way. They tried a bunch of different materials, and then they did some more technical characterizations trying to understand how the clay would be deposited and show a bunch of pictures around that. Tried a bunch of different shapes. So here they have this kind of Voronoi pattern, which winds up with all these little bubbles. Tried some text. They used circles as basically masks for holes. These are all post-processed, but kind of as the starting point for making the hole. Most of what they did and showed wind up being tiles, and this kind of makes sense with their application. So this is basically, so the bottom of the tile is the one that was on the plaster, and so you can see the difference in depositing of clay on the other side. They used the resists as basically ways to get thinner clay that they then carved out manually. So that's what these examples are, and I think that's a reasonable thing to do. Basically gives you a guide for carving. And then they made this lamp where the resist on the inside makes the clay thinner, so it's more translucent. And I think this is probably the most compelling example, or the one that's most aligned with traditional processes. So when the lamp's off, you basically wind up with a smooth surface, and then when the lamp's on, because of the thinness of the ceramic, the light shows through, like in a porcelain clay body. They had another example where they made a slab and then turned it into a slab-built pot. For a lot of these patterns that are basically the tiles or the slabs, I think it would probably be easier just to use a roller that has the pattern built into it. I talked with the author after the paper. He said that the vinyl is just a lot faster than making the rollers, which I kind of buy. Although 3D printing a roller isn't that complicated, so I'm not exactly sure there. But overall, this was cool to see, and I think it shows some interesting explorations in the space. Maybe there's some interesting ideas that other people have and can take this and move it to the next level. Next up was this paper, American Indian Pottery and Clay 3D Printing, an exploration of opportunities and risks in professional practice. This paper was done out of the University of New Mexico, and they've been doing a variety of ceramics-based investigations using technology. They've done several pieces of work around using clay 3D printers. And this paper is interesting because they actually had some professional artists come in and basically do a residency playing around with the technologies and trying to understand how they might impact their practice. There's a couple of other things that this touches upon that I also found very fascinating. One is basically the tradition of American Indian pottery. So there's this very rich cultural piece to making pottery, and these were experts in that field. This is what they did. And it also touches upon what it does mean to be a professional using some of these technologies. Basically, the only way this happened was because the university was able to support these residencies to come in and do these explorations. I thought about doing something similar. I think it'd be really interesting to do some sort of residency program, but I'm not too sure about the logistics of that. So the artists came in and they basically used some of the 3D printing technologies to explore a bunch of different works. So they were learning the technology as well as exploring their ceramics forms. And so the paper touches upon a variety of topics. So one is around this notion of traditional pottery and what that market looks like. There is an association, SWAIA, that they were a part of that holds a big event, and lots of ceramics are sold. There's judging, and there's this really interesting tension between traditional and contemporary. I think in general it seemed like this organization leaned very traditional, although there was a contemporary category, and at least one of the artists submitted their work under that category. In the paper there's a background of the artists and some of their work. So here were a series of 3D printed mugs that one of the artists made and then kind of used a more traditional process in terms of firing them. One of the things he talked about was actually doing a bust. This is something he had thought about for a long time, and it wasn't until this residency program that he gave it a shot. This is an example of the piece, starting with a 3D render, going all the way to the finished piece. They won some awards in the contemporary pottery category, which was cool to see. To talk a little bit about the challenges of using 3D printing and clay. Basically, the model and the clay don't necessarily do the same thing. There's another piece of work that the lab did that was probably inspired by these failures here, and basically they made a new slicer for the clay 3D printer to overcome some of these challenges. Talk about the overall process, so doing everything in CAD. They went up and designed everything, slicing it, getting all the materials ready, printing, and some of the cleanup steps. After the program, there were definitely some takeaways, and I think at least one of the artists incorporated some more of the ideas that he explored during the residency, although he wasn't using a 3D printer. He wound up doing it in a traditional process, and one of the comments from the talk was he wasn't going to be using 3D printing going forward. But I think leveraging these new technologies to push in new directions was an interesting kind of artistic exploration. And here are some of his pieces after the residency program that show some of the kind of inspiration he got from doing it. There was a lot of discussion in the talk, in particular around technology versus tradition. I think this comes up with slip casting quite a bit as well, where slip casting isn't real ceramics and things like that. There were definitely pushback from the community of using 3D printing approaches to make this type of pottery. And there was a variety of comments from the professional organization in terms of using the 3D printing, and mostly negative. So I think this is really interesting in terms of investigating what does it mean to pull new technologies in traditional crafts. Slip casting itself is new and old. Like in the scope of ceramics, ceramics is thousands of years old versus slip casting is maybe 100, 150 years old. So it too is relatively new. And for something like art, where tradition is really valued, new processes and techniques can be frowned upon. At the same time, they create new media, and I think anytime new media are introduced, there's both the old guard kind of pushing back and then this opportunity to go and explore new things. The invention of photography, like, oh, you're not painting anymore, that's not real art, versus now I think it's very clearly accepted that photography is an art form. So kind of using the backdrop of clay 3D printing, this work investigated that space, which was cool. Both of those were full papers, so they basically go through full peer review, and the acceptance rate's pretty low, the competition's pretty high. This paper here was late-breaking work. These are meant to be smaller contributions. They're still peer-reviewed, but not to the rigor. They're meant to be smaller and sometimes earlier contributions. So this one was looking at conductive ceramics, embedding electronics in everyday ceramic objects. Came out of MIT and Harvard. And what they were looking at is basically, can we have conductive materials inside a ceramics piece that we can then kind of marry up with traditional electronics devices? There had been some earlier work where they took a ceramics piece and then applied a conductive ink or paint on the surface of the ceramics. So it wasn't purely ceramics anymore, and they investigated a variety of things you could do with that. In talking with the author of this work, Sam, she really wanted to try and use more traditional ceramics processes to basically accomplish something similar. So she wound up using silver glaze, basically a luster, as the conductive medium and explored different ways to do that. So they made a silver glaze recipe and did some early firings, looked at it under the microscope so they could see what the structures looked like, did some testing for the conductivity, then experimented with the design space, trying to understand the different parameters involved. Then they made a vessel with some electrodes basically embedded in the wall. So this is the silver glaze that's been applied to some areas. And they hooked up a power supply. So the silver ceramic has resistance to it. And if you apply current to that, it'll heat up. Basically, it's a resistive heater. This is a thermal image showing the conductive glaze getting warm, and potentially you could have like a self-heating mug. It's kind of an idea they were playing with. And then they went the other way. So they made a candle holder with, again, a bunch of traces on the outside. And then they measured the resistance, and this wound up being a resistive temperature sensor. They explored a bunch of different techniques. One of the other things they did was playing with kintsugi. So they took a piece, and then basically in the traditional kintsugi process, you reassemble it. I think this is often done with gold and enamel, and they used their conductive, and they played around with some ideas around there, as well as a few other explorations. I'm not too sure exactly what I would do with conductive traces in my work, but I think in terms of like pushing the boundaries of what's possible, it was definitely interesting to see. And then the last paper I want to talk about isn't ceramics, but it's ceramics adjacent. So this came out of the same lab at the University of New Mexico, and they were looking at using their clay 3D printer. Instead of printing clay and ceramics, they wanted to 3D print glass. So here are a bunch of examples they made using their process. And so they have what they call cold glass. They turn it into a paste. They then print it on a printer, fire it, and they wind up with a glass object. And here is the recipe they use to make their 3D printable glass. Basically, it is almost all glass frit, and then they have some other additives in it to basically make it stick together and be fluid and work in their printer. So they basically are printing out this glass frit, and then once it's fired, it all gets sintered together and turns into glass. And I was looking at these temperatures, and I think it's fired to something around cone 018. So relatively low temperature in terms of ceramics. So here's the firing schedule they use. A lot of the paper is really around kind of creating this material and how to get it to work. They did a bunch of different tests, for instance, looking at slumping when it gets too hot. how glossy is the surface finish if they don't fire it hot enough. It has a very matte, doesn't bind together because it doesn't center together. They have some software that lets you kind of parametrically create some designs. So I think this was used to generate some earrings. They explore kind of different colors and how they interlock and what happens when they get fired. So here's an example here of glass tiles. Here you can see kind of the artifacts from the 3D printing and the lines and what they look like after they're fired. Exploring around with different slicer settings, basically getting different surface finishes. And they also talk about like the life cycle of the overall thing. So basically being able to reuse it at different points. Before it's fired, they can basically just crush it back up and reuse it as is. So somewhat similar to clay. Even though you've made a pot with your clay before it's fired, you can basically break it up, add water again, and then reuse it. This material is similar, or after firing, because it's glass, it's actually relatively easy to recycle the glass, which is different than the way clay and ceramics works. And then they basically explore the design space, playing around with different effects, different shapes, being able to attach pieces together because they couldn't be printed all as one piece. Printing on top of plate glass, so this wound up with some selective melting and kind of going into the underlying substrate. So again, not ceramics, but kind of using some ceramics adjacent technology and some similar processes, and I thought it was pretty cool. So something a little bit different for my channel, but shows you a little bit more of the background that I'm in. This was my first paper on ceramics itself. I'd done a bunch of other things before that are in this field. And overall, it was cool to see a bunch of different ideas and maybe get some inspiration from them. I'm not too sure exactly where they'll go, but one of the things I do is collect a bunch of random things, and eventually sometimes a new idea emerges and it winds up being interesting and I want to push it forward. I'll go ahead and leave links to these papers in the description below. If you're curious, you can dive into the PDFs themselves, which is how research is actually put out into the world. Or there's also links to videos that the authors put together. You should be able to see those. I think those get linked to YouTube. That way you can see the authors present their own work. I hope you found that interesting as well. If you have any questions or comments, let me know. Thanks.